Welcome to my YouTube channel. I am Professor Amira Samir, a mathematics teacher. If you like the channel's content, don't forget to press the like button and press subscribe to receive all the new lessons. Unit 1, lesson number 2, factorizing number to its prime factors, G.C.F and LCM. First, let's answer the previous homework. If the total price of 25 books is £1,875, let's get the price of each one book. To get the price of each book, I have to divide 1,875 by 25. It will be £75. And after that, to get the price of 35 books, now we have to multiply the price of each book by 36. So 36 times by 75 equal £2,700. Number 2, Hossein bought a car and paid £75, £500 as a down payment, and the rest he divided by 24 equal monthly installment. Okay, and the total price of the car is £163,500. How can I get the value of each installment? First, we have to know the rest of the car's price by subtract the total price of the car minus the down payment. So 163,500 minus 85,500. The answer is £78,000. Now I have to share this amount by 24 months. So each month I have to pay £3,250. Let's start by G.C.F. First of all, we have to know what the meaning of prime numbers. The prime number is a whole number. It's not a decimal. It's a whole number that has exactly two different factors. One of them 1, and the other factor is the digit itself. A composite number is a whole number that has more than 2 factors. Let's see examples. How can I get the factors of 1? I can get 1 by multiply 1 by 1. So it has only one factor, which is 1. If we have repeated number, we take only 1. So 1 has one factor, which is 1. The factors of 2, I can get it by multiply 1 by 2. It has 2 factors. One of them 1, and the other one the digit itself. 3, it has 2 factors, 1 and 3 itself. 4, it has 1 times 4, 2 times 2, so 3 factors, 1, 2, and 4. So it's not a prime number, it's a composite number. Number 5, 1 times 5, 2 factors, one of them 1, and the other number is 5 itself. 6, it has 4 factors, 1, 2, 3, and 6. It's a composite number, not a prime. And so on. 7, 8, 9, 10, and so on. All the circled numbers are prime. Okay. So this chart shows you the prime numbers. The purple, the shaded square are prime numbers. Okay, so these are the prime numbers. Remember that 1 is not a prime number because it has only one divisor or one factor. As we said here, it has only one factor, which is 1. Next, 2 is the smallest prime number. Let's return. The smallest prime number is 2. Next, all the prime numbers are odd except 2. Let's see here. 3, 5, 7, 11, 13, 17, 19, 57, 67, 89, 97. All of these are odd numbers except 2. So all prime numbers are odd except 2. But not all the odd numbers are prime. For example, we have here 9. Is it a prime number? No. Why? Because I can get it by multiply 1 by 9 and 3 by 3. So it's not a prime. It has 3 factors. 1, 3, 9. So it's a composite number. And also, let's see 15. It's odd, but not a prime. Why? I can get it from 1 times 15 and 3 times 5. So it's not a prime. The same in 21. I can get it by multiply 1 by 21, 3 times by 7. So all the prime numbers are odd except 2, but not all the odd numbers are prime numbers. 3 is the smallest odd prime number. 3 is the smallest odd one. And if I look to this chart, all of these are odd. The smallest one is number 3. There is infinite number of prime numbers. This is up to only 100. But if I complete, I have infinite number of prime numbers. Complete with prime or composite. 2 is prime, correct. 4 is a composite. Any even number is composite except 2. So 4 is composite, 6 is composite, also 16 is not a prime, it's composite, and any 12 is composite. Any even number is a composite number except 2. But not all the prime numbers are, as we said, not all the odd numbers are prime. 29, let's check our chart. You have to study these numbers. 29 is a prime number, okay? So it's a prime. 5 is a prime number. 7 also prime. I can get it by multiply 1 by 7. 11 prime. 13 prime. 23 is a prime number. 21, no, it's not a prime. I can get it by 1 by 21 and 3 by 7. It's not a prime. 27, it's not a prime. I can get it by multiply 3 by 9. 9, it's odd, but not a prime. I can get it by multiply 3 by 3. 15, it's also not a prime number. I can get it by multiply 3 by 5. So any even number is a composite, except 2 is a prime. And any odd number, it's maybe a prime, maybe composite. Let's complete. Dots is the only prime number, and it's even. It's 2. 2 is the only even prime number. Number B, the prime number has 2 factors, which are exactly 1 and the digit itself. Number C, 1 is not a prime number because, yes, it has only 1 factor. Number D, the 2-digit prime number which is less than 13. The prime number less than 13, 2, 3, 5, 7, 11. Which one has only 2 digits? It's 11. Number E, all prime numbers are odd except, yes, 2. Let's know how can we write a number as a product of prime factors. Product means the answer of multiplication. So how can I write any number as a product of prime factors? Means multiply prime factors to get the number. Or he can ask you, find the prime factorization of each number. Let's see an example. 36. We will use the prime factor tree. Prime factor tree. Write 36 as a product of 2 factors. And continue until the branches and the prime numbers. Let's see how. This is 36. How can I get 36? By multiply 2 by 18. 2 is a prime number. So I can put here a circle and complete the other branch. 18, how can I get 18? By multiply 2 by 9. 2 is a prime factor. So I can circle this number, then go to 9. How can I get 9 by multiply 3 by 3? Now 3 is a prime, 3 prime, 2 prime, 2 prime. Let's see another method. I can separate 36 to be 6 by 6. I can get 36 by multiply 2 by 18 or 6 by 6. 6 times 6. How can I get 6 by multiply 2 by 3? 2 is a prime and 3 is a prime. Now I finish this side. Let's take the other side or the other branch. How can I get 6 by multiply 2 by 3? Now I have the same answer. 3, 3, I have here 3, 3. 2, 2, I have also 2 and 2. Another method. How can I get 36? I can get it by multiply 2 by 3 by 12. 3 is a prime number. So let's go to 12. How can I get 12 by multiply 3 by 4? 3 is a prime. Okay, go to 4. It's a composite. How can I get 4 by multiply 2 by 2? Also, I can find 2 2's and 2 3's. So the product of prime numbers is 2 times 2 times 3 times 3. Let's try كده to multiply. 2 times 2, 4. 4 times 3 equals 12. 12 times 3, 36. So I can get 36 by multiply 2 by 2 by 3 by 3. And all of these numbers are prime. How can I find the prime factors of 24 as product of prime factors? First, I can use the factor tree. 24, I can get it by multiply 2 by 12. 2 is a prime number. Go to the other branch and factorize. 12, I can get it by multiply 2 by 6. 2 is a prime number. Go to 6. I can get it by multiply 2 by 3. So the answer is 2 times 2 times 2 times 3. Can I get it by another method? Yes, of course. I can get it by multiply 3 by 4 by 8. 3 is a prime number. Let's take 8. I can get 8 by 2 by 4. 2 is a prime number. Let's take 4. I can get it by multiply 2 by 2. The same answer. 2, 2, 2 times by 3. 24. I can get it by another method by multiply 4 by 6. 4, I can get it by multiply 2 by 2. 2 is a prime and 2 is a prime. So I finished this branch. Let's go to the other branch. How can I get 6 by multiply 2 by 3? So the prime factorization of 24 is 2, 2, 2, 3. Let's check. If I multiply 2 by 2 equals 4. 4 times 2 equals 8. 8 times 3, 24. So these are the prime factors of 24. Find the prime factors of 48. How can I get 48? I can solve by any method. In the answer, you can use only one method. 48, I can get it by multiply 4 by 8 and 6 by 2 by 3. 8, 2 by 4. 2 is a prime. Let's take 4. How can I get 4 by multiply 2 by 2? So the answer is 2, 2, 2, 2, and 3. 4 2's and 1 3. Now, 48, how can I get it? 2 times by 24. 24, I can get it by 2 by 12. 2 is a prime. Let's take 12. I can get it by multiply 2 by 6. 6, I can get it by multiply 2 by 3. 48, how can I get 48 in another method? 3 times 16. 16, I can get it by 4 by 4 or 2 by 8. Okay, here also I can get it by 2 by 8. Okay, 4 by 4, I can get it 2 times 2 and 4 2 times 2. And here 8 2 times 4 and 4 2 times 2. So the answer always, we have 4 2's and 1 3. So here 2 times 2 times 2, I have to add another 2. Then times by 3. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times by 3 equals 48. So these are the prime factors of 48. Find the prime factors of 16. 16. How can I factorize 16? I can get it by multiply 2 by 8. 2 times 8 equals 16. 2 is a prime number. Let's take 8. I can get 8 by multiply 2 times by 4. 2 is a prime number. Now let's go to 4. I can get it by multiply 2 by 2. So to get 16, I have to multiply 2 times 2 times 2 times 2. Can I get it in another method? Yes. 16, I can get it by multiply 4 by 4. And 4, 2 times 2. And this 4, 2 times 2. All numbers are prime numbers. So let's check. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. So your answer is correct. So you can get 16 by multiply 2 times 2 times 2 times 2. Find the prime factors of 45. I can get the prime factors of 45 by multiply 5 times by 9. Then prime factors of 9, 3 times 3. So the prime factors of 45 are 3 times 3 times 5. Can I solve it in another method? Yes. I can get 45 by multiply 3 by 15. 3 is a prime number. Let's go to 15. I can get it by multiply 3 times by 5. So 3 times 3 times 5. So 3 times 3, 9. 9 times 5, 45. So I can get the prime factors of 45 by multiply 3 times 3 times 5. 3 and 5 are prime numbers. Find the prime factors of 30. How can I get 30? I can get it by many ways. 30, 3 times 10. And 10, 2 times 5. 3 and 2 and 5 are prime numbers. Another method. 30, 5 times 6. 5 is a prime. Let's go to 6. I can get 6 by multiply 2 times 3. 2, 3, 5 are prime factors. 30 in another method. I can get it by multiply 2 times 15. And 15, I can get it by multiply 3 times 5. 2, 3, 5 are also prime factors. So I can get 15 by multiply 2 times 3 times 5. Let's check. 2 times 3 equals 6. 6 times 5 equals 30. So your answer is correct. Now, how can I get the greatest common factor? G.C.F. If I have two numbers or more, how can I get the G.C.F.? Okay, first I have to factorize each number to its prime factors. So take 12 and get its prime factors, and get 24 and get its prime factors. Then find the common prime factors between 12 and 24 or any other two numbers. Then find the product of these common prime factors to get the G.C.F. Let's see this example. 12 and 24. 12, I can get it by multiply 2 by 6. 2 is a prime. Let's go to 6. I can get it by multiply 2 times 3. These are prime factors. So let's go to 24. I can get it by multiply 4 by 6. 4 is a composite. How can I get it by multiply 2 by 2? These are prime factors. Let's go to the other branch. 6, I can get it by multiply 2 by 3. Now I have 2, 2, 2, and 3. Let's write 12 and 14 and write the prime factors of 12. 2 times 2 times 3. 2 times 2 times 3. 2 times 2, 4. 4 times 3, 12. How can I get 24? 2 times 2 times 2 times 3. 2 times 2, 4. 4 times 3, 12. 12 times 2 equals 24. But take care when you write these factors. When you write these factors, I write here 2, 2, and 3. These numbers. Now, when I write these numbers, I have to put 2 under this 2, and this 2 under this 2. And this 2, I don't have this 2. I just have here 2 2's, so I have to put it out. Then put 3 under 3. Now we have to get the common factors. I have here 2, take only 1. And I have here 2 and 2, take only 1. 3 and 3, take only 1. Then multiply these common factors. 2 times 2, 4. 4 times 3 equals 12. So the greatest common factor is 12. What the meaning of greatest common factor? I can divide 12 by this 12 without remainder, and also I can divide 24 by 12 without remainder equal 2. Okay, so this is the greatest common factor between 12 and 24. First, we have to get the factors of 12 and get the factors of 24. Second, we have to find the common prime factors between them. But when I put the factors on each others, I have to put 2 over 2 and 2 over 2, 3 over 3. And I don't have here 2, so put it out. Then find the common prime factors between them. Then multiply these common factors. Let's go to another example. The GCF of 15 and 36. First, factorize 15, 3 times 5. 36, I can get it by many methods. I will get it by 6 by 6, then factorize 6 to be 2 times 3, and 6 to be 2 times 3. Now, when I write 15, I write 3 times 5. When I write 36, I have only 1 3 common, okay? Then this is 3 like this. Okay, but I don't have 2, I don't have 2, I don't have 3. So put these numbers out. Okay, then from 3 and 3, I have only 1 3. So this is the GCF. It has only one common factor between the two numbers, which is 3. So this will be GCF. That means I can divide 15 by 3 without remainder, and can divide 36 also by 3 without remainder, and this is the greatest common factor. How can I get the GCF of 3 and 17? 3 and 17 are prime numbers. Take care, 3 and 17 are prime numbers. So when I get 3, I can get it by multiply 1 by 3 itself, and 17, 1 times by 17. So no common prime factors. Now the GCF is 1. Why? Because 1 is a common factor between 3 and 17, and 1 is the common factor of all the numbers, because all the numbers I can divide it by 1 without any remainder. The GCF of 8 and 9. We will factorize 8. 2, 2, 2. 9, 3 by 3. Let's put 2 times 2 times 2, but I don't have here any 2, so I will put 3 and 3 outside. No common prime factors, so the GCF is 1. So when I don't have any common factor, always the GCF will be 1. The second way to get the GCF by using the Venn diagram. How can I get the GCF of 18 and 24? So I can factorize each number to its prime factors. 18, 3 times 6, 6, 2 times 3. 24, 4 times 6, 4, 2 times 2, 6, 2 times 3. Then write 18, I can get it by multiply 2 times 3 times 3. Now let's write the factors of 24. 2 times 3, 2 times 2 times 2 times 3. How can I write this? I have to write this by put 2 under 2, 3 under 3, and 2, 2 outside. Now the common here is 2, and the common here is 3. The GCF when I multiply 2 by 3. How can I show this in Venn diagram? The prime factors of 18 are 2, 3, 3. But I have here 2 common with 18 and 24. So I will write the common here, 2 and 3. So 2, 3, 3. I have 2 is common between 18 and 24. 3 is common between 18 and 24. So I will put 2 and 3 here. And the rest, I have to put it in the prime factors of 18. And this 2 and 2, put it in the prime factors of 24. So in this circle, I can find in this place the prime factors of 24, and here the prime factors of 18, and the intersecting area between 18 and 24, I can find 2 and 3. When I multiply 2 by 3, this will be 6. Venn diagram can be used to compare the similars. Venn diagram can be used to compare similarities and differences between items where the circles overlap is where information is shared. So if the two circles overlap, so it will be the same number. Homework. The GCF of 10 and 15 is number B, from the opposite Venn diagram. How can I get the GCF? Number C, which of the following are relatively prime numbers? Number E, which of the following is not prime number? The answer will be in the next session. Thank you. See you next time, inshallah. Goodbye.